congruent solids are solids that have exactly the same size and shape. They're exactly the same. Similar solids are solids that have the exact same shape, but not necessarily the same size. Both could be pyramids, but one pyramid is small and the other one is a big pyramid. Yes, here. Oh, quickly. All corresponding dimensions of similar solids are proportional. Just like what we did in Unit 3, you take the corresponding sides, make them into a fraction, and simplify. If the fraction's the same, those figures are similar. If the fractions aren't the same, then they're not. Essentially, we're doing what we've done in a previous unit all the way in first semester. So look at A. We wanted to figure out if these solids are similar. If it is, then we're going to write the scale factor. Well, just like we did in Unit 3, we have 3 parts, so we're going to have 3 fractions. Make sure these parts match up. So it's important to make sure the heights match up. So in this first figure, what's the height of that prism? 20. So then go to the other prism. What's the height in that one? Alright. Move on to the next fraction. And I like to cross them off as I go. So now I'm done using them. Here we have 5. Which part of this prism matches up with 5? 2. Cross them off as I go. And here, our last one is 15. Which side matches up with 15? 6. Make sure you stay consistent. We put the height of the first figure in the top, so the rest of those values in the top have to be from the first figure. The second figure was in the bottom, so all the other fractions have to have the second figure in the bottom. So simplify. What is 20 over 8 simplify down to? 5 over 2. What is 5 over 2 simplify down to? 5 over 2. Already simplified. And then what is 15 over 6 simplify down to? 5 over 2. Did we get the same exact fraction every time? Yes. Yeah, so are these figures similar? Yes. Yes. So because they're similar, we must state the scale factor. What's the scale factor?
5 over 2.
5 over 2. It's that simplified fraction you get every time. Same kind of steps with B. We have 3 parts, so we are going to have 3 fractions. Match up the heights. What's the height of the first figure? What's the height of the second figure? 7. Those are going to match up. Height of the first, height of the second have to match up.
Pretty sure they can be simplified.
Alright, we'll see that here in a second. Here we have 12. Which side matches up with 12?
8.
So we match 10 and 7, we match 12 and 8. And then if you notice, we have the exact same fraction for that third one. So you don't necessarily have to write that one down when they're the same. We're going to just for practice. Well, what does 10 over 7 simplify down to?
Nothing.
No, it stays 10 over 7. It's already simplified. What does 12 over 8 simplify down to? 3 over 2, and that's going to simplify down to 3 over 2 because they're the same fraction. Are these the same?
No.
No. So are these figures similar?
No.
No. They're not. So because they're similar, there's not going to be a scale factor.
No brownie faces? No put brownie faces in the notes? We did this earlier today. A bunch of people put brownie faces in the notes. No brownie face. Alright, well, here's where we're doing, we're getting ratios. Let's see if we can still keep getting ratios in other scenarios. Because we can. The ratio, so first off, the ratio to the first power is just be a scale factor. Let's go through and still explore more of these ratios. Determine the scale factor between the two prisms. Well, we just did that. We want to figure out how the sides compare to one another. So again, we're going to match up the common sides, common pieces. So over here, again, we just go left to right. Some people like to go small over large, big. It doesn't matter. Just stay consistent. For the sake of this, I'm going to go left to right. And let's see what matches up. So again, we're going to make up those ratios and see what we have. Let's start with the one on the left. If I say 2, what segment matches up with the 2 in the other prism? 4. We'll reduce later. All right, let's go on to the next one. If I say 1, what matches up with the other one? 2. And then the last one, we go to the heights. We do 3 over 6. Let's see what we got here. We should always reduce our fractions, reduce our ratio. 2 over 4 becomes?
1 over 2.
That is correct. Get out your calculators. 1 over 2 becomes? Yeah, no need for that. And over here, 3 goes to 6. 1 over 2. So, are these figures similar?
Yes.
Yes. They have the same scale factor? Yes. What is that scale factor?
1 over 2.
1 over 2. 1/2 is your scale factor. Awesome. Well, now it says, let's determine the volume of each prism. All right, well, you guys took a quiz over that the other day. Let's do the same thing. What you should do this entire unit is look at the shape. Determine what shape it is. Write down that formula. These are obviously prisms because it says prism. So we're going to have to write down the formula for a prism. What is the volume formula for a prism? Base, something special about that B. Big B. Big B. So there's a difference. And then since we have 2 prisms, we're going to have 2 of them. All right, so just like before, we write down the formulas. We figure out what pieces we need. I need a base, a big B, and I also need a height. All right, we'll do the little one on the left first. Just because it's left to right. I don't care how you do it. What sort of base is that? And again, a rectangular prism, it doesn't matter which one you call the base. But for the sake of what we're doing, let's just call the one it's sitting on its base. It doesn't matter. So, what is this base? What shape is it? Not technically a square. It's a rectangle. How do you find area of a rectangle? Now here's where you can say it. It's base times height. And we're just talking the 2-dimensional figure, that bottom piece. So the base of the base, we'll call it 2. What is the height of that base?
4.
The height of this base is 1. That's hard to shade in there, but it's 1. So my big B is 2 times 1 is 2. What is the height? Now that's the distance between the bases. We call the thing at the bottom of the base.
3.
It's now a height of 3. I've got the big B, I've got the height, I've got enough to find its volume. So V equals big B. You guys told me that is 2. A height of 3. Well, that gives me a volume of 6. Volume of 6 of the little guy. Well, I bet the bigger one's going to be larger. Let's find out. The same exact thing. I need to find that big B. I need to find that height. We've got enough. Again, it's similar. We already established similar. So the bottom, the base, is still going to be a rectangle. So here's my base I'm looking at. The base of the base, let's say 4. If you called it 2, it doesn't matter because they're going to ultimately multiply together. And the height of that base is 2. 4 times 2 is 8. And what's the height? 6. If it's sitting on space, how tall is it? It's 6. Or the distance between the bases. Either way. We still have everything we need. I got my B, got my H. Let's solve. Big B is 8. Height is 6. 8 times 6 is the A. 48. Great. So we now know the volumes. Well, let's figure out the ratio of the volumes. Like, what is the percentage? What's the volume, the ratio of how much bigger that one is compared to the other one? Or vice versa. How do we look at it? Well, just like we did our scale factor, we took the sides, we took the small one or the large one, and reduced our fraction. we're still going to do the same thing for this one. So the volume of the little one, we said was 6. The volume of the large one is 48. And we want to find this ratio. So you just take your calculator. What is 6 over 48 reduced down to?
1/8.
1/8. And that is your ratio of your volume. Well, look at these ones here. And let's think about this a little bit. Think about some of our knowledge. A scale factor. That's just talking about like the sides. I have a 1-to-2 ratio of the sides. So that's the other side's twice as big. Well, let's think about volume. What is volume measured in? Think about when you're labeling your units. What do volumes always have? They always have what? They're cubed. They're cubic. Not necessarily, in this case, meters, yes, but not always meters, but they're definitely cubed. If I do 2, if I do a side, I cube it, that would make a 3-dimensional figure. If I do 2 cubed, what's 2 cubed?
2 cubed.
It's 8, isn't it? Well, look at this. Go to scale factor. If I cube that number, I will get 8. And that always works. It brings you this little theorem we have. The area and volume similar solids. So basically what it says is this. Whatever your scale factor is, that's in the first dimension, just measuring something out. If I take those terms and I square them, I get the area. I get the ratio of the area. And then the other way around, if I take that scale factor and I cube it, I'll get the volume, the ratio of the volumes. So we could have got this answer without ever having to do all this work. We said, oh, there's a scale factor. Well, I know I would cube these numbers, and I would have got 1/8. So it's a little shortcut helping you solve some of these things. We'll do more examples here in a bit. Questions on that? This, you know where it's at. I don't know. It's hidden there.
It's hiding. Okay.
Oh, that's easy enough.
Okay, you look at example 2. We know the following figures are similar. We want to find the scale factor. Okay, well in A it says 2 similar prisms with a surface area 144 meters squared and 324 meters squared. We need to find the surface area. Okay, well these problems don't necessarily have a lot of work, particularly if you have a calculator, and even easier if you have a graphing calculator. So have that out on your desk so you can practice entering this in.
Everyone has to practice this. So I'll come around. If you're not getting the numbers we get, raise your hand. I will assist you.
Okay, so in your calculator, your first step on your paper is to make a ratio of those surface areas. So we're going to do 144 over 324. We just like to do small over big. Do big over small, not the end of the world, but this is what you're going to see us do. Okay. Just like we talked about in that theorem. The ratio of the surface area, or the scale factor, if you square it, gives you the ratio of those surface areas. So the first thing you need to do, set up the fraction, then simplify it.
4/9.
We can easily simplify it by using your calculator. So if you have a graphing calculator, what you can do is just say alpha y equals enter, and that gives you your fraction bar. And then you just do 144, arrow down 324. And what do we end up getting? What? You have a question of your calculator? What do we end up getting when we enter that in?
Oh, it's 44.
What do we end up getting? 4/9. If you did not get 4/9, make sure you raise your hand so you can help somebody help.
Not get that. Especially if you're borrowing a calculator. Try this.
Okay.
We'll help you.
So set up the ratio, simplify the fraction. Now that we simplify the fraction, we can find our scale factor. And that theorem, we said, to get the ratio of the areas, you square the scale factor. Square the top, square the bottom. Here we went backwards. You were given a ratio of the areas, and we're trying to find the scale factor. So if we're going backwards, we have to do the opposite. So instead of squaring,
Square
we
root.
will square root. The square root of 4 is what? The square root of 9 is, there's your scale factor. So again, first step, set up the ratio, simplify the fraction. If you're given areas, you're going to square root to get your surface area. Okay, take a look at B. We were given two cylinders that are similar, and their volumes. So just like we did in the A, we're going to set up that ratio. Small volume over the bigger volume. Set up ratio, then simplify it. What's going to happen with those pies? Yeah, they're going to cancel out. They seem really overwhelming at first, but they cancel out. So you don't have to deal with them anymore. And then again, in your calculator, simplify that fraction. 135 over 320. What do we get when we simplify that fraction? Good. We get 27 over 64. Well, we said if you're given the scale factor, you cube it to get the ratio of the volume, okay? Well, again, we're going backwards. We were given the ratio, now we're trying to find the scale factor. You kind of have to think. If the opposite of squaring is square rooting, the opposite of cubing would be cube rooting. So you can cube root this. Okay? Some of you might be super overwhelmed. You're like, I don't know what cube roots are. Okay, well, your calculator again will do it for you if you're not sure. So in your calculator, your graphic calculator, if you're trying to do a cube root, you're going to hit this math button. It's right below that green button. Hit math. And then if you notice here, there's that square root symbol, but it has a 3 in front of it. That means cube root. So you're going to press 4 or arrow down to 4. Now you have a cube root, you just type in the fraction. You do alpha, y equals, enter, and you're going to do 27 over 64. And then hit enter. What do we get when we hit enter? You get the cube root of 27 is 3, the cube root of 64 is 4, so our scale factor is 3 over 4.
Make sure you're knowing how to do this. Let's get questions.
And most of this is just plugging things into your calculator. Really, all the work you have to do is writing it down on paper, plug it into simplify, plug it into square root. Write down the fraction, plug it into simplify, plug it into cube root. You got your answer. Then if you want to make a note, you can say math. Put like math and then 4, and it gives you the cube root symbol more than a total. So, question, you're doing this on your own. Example 3, we were given two cubes that have the sides like 4 centimeters and 5 centimeters. Find the ratio of the volume. Okay, well, take your scale factor. Small side over the big side. There's your scale factor. You take one side, put it over the other corresponding side, you have your scale factor. What did we say we do to the scale factor to get the ratio of its volume?
You cube root it.
Not cube root. You're going from scale factor to volume. You don't cube root, you just cube. Scale factor to volume, you cube. Volume to scale factor, you cube root. You do the opposite. So it's 4 cubed.
64 over 125.
And And then 5 cubed, as Gary said, is 125. There's your ratio of the volume. Not a lot of work, you just have to remember those rules. A lot of it's just using your calculator.
Yeah, that calculator is a helpful tool. You just have to really figure out what piece you're given and how to get to those other ratios, whether that's scale factor, surface area, or volume. So, why is this helpful? Because if you have one known ratio, you can figure out missing pieces of another figure, whatever it is. That's why similar figures helps out. That's an example of what we have here. So number 4, the surface areas of two similar figures are given. The volume of the larger one is given. Find the volume of the smaller one. So we know the surface area, but we only know the volume of the large one. How do I figure out what the volume of the small one is? We'll show you with these ratios. It's just like you did before. You figure out which one do I have 2 of them? Which one can I set ratios to? Do I have 2 surface areas or 2 volumes? Which ones do I have? 2 surface areas. That's my ratio. I'm going to make the ratio of the surface area. So let's go ahead and do that. And again, for this, it doesn't matter how you set this up to stay consistent. We like to do the small one over the large one. It doesn't matter. So we're going to do 16 over 100. That's what it gave me for the surface area. Well, what do I need to do to this to get its ratio? And what do I do to every fraction, really? Reduce. And when I reduce 16 over 100, I get 4 with this. Great. Well, that is the ratio of the surface area. Awesome. What I like to do, is very helpful, is we're going to do a little chart. Because the next thing we need to go to is always, no matter what you're given, your next one, just like we did back here, is you always have to get that scale factor. So we got to get the scale factor. So that's why I have this little chart to help you out. It looks like this. The first one is FF. SF, excuse me. What's that stand for? That stands for scale factor. Then you have SA, which is surface area, and then you have volume. What ratio is this? What did we reduce down? Of those 3, which one did we reduce down? Volume, surface area, or scale factor? Surface area. So my ratio of the surface area is going to be 4 over 25. We always need to go, and here's another thing too I'm going to put on here. This helps me out, especially early on. That's to the first power, this is the second power, volume is always to the third power. I always need to, on this chart, go to scale factor next. How do you go from surface area to scale factor? What's surface area measured in? What are the units in that? Squared. So how do I go back to something that's in the first power? On square, which is? Square root. So we're going to square root this, and then we'll get what our ratio is of the scale factor. So when I square root 4 and 25, what's the square root of 4? 2. What is the square root of 25? There we go. So there's that. Again, this is the process we do every single time for this. I now have the scale factor of this equation right here. Now, notice there's one more blank on this. I need to solve that blank. How does someone go from scale factor to volume? It goes back to over here on that little notes we had. How do I go from scale factor to volume? What do I have to do to that ratio? Someone said it. I have to cube it because I'm going to the third power. So I have to cube it. So what you have to do to these is cube these answers. They're increasing that way. So I'm going to do 2/5, and by 3, I'm cubing them. What's 2 cubed? 2 times 2 times 2 is 8. What is 5 cubed?
125.
We already found that, so it's nice. You need all of these ratios to move on to the next thing. Now, this is where it gets really easy with this. These are all my ratios. Ratio scale factor, surface area, and volume. First power, second power, third power. Easy. Now, I need to find that missing piece. So, what am I trying to find? I'm trying to find what? Surface area, scale factor, or volume. I'm looking for find the volume. Which ratio do you think I'm going to use? The volume one. Makes sense. So I'm going to do the volume ratio, 8 over 125. That's equal to, I know these are similar figures, I know they're proportional. So if I know this is the ratio, I already know what one of the volumes is. Which one is this? This is where you got to read a little bit. Is this the smaller one or the larger one? It's the larger one. In a ratio, which one do you think in a fraction? Do you think the top one's going to be the larger one or the bottom one? The bottom one. So this goes down here on the bottom. 500. And this one we don't know. We're trying to find that volume. How do you solve a type of problem like this? Cross multiply would be a good one here. Cross multiply. I'll help you out. 125 times V. I'll give you that. Just 125V equals, what's 5 times 8? 40. Add 2 zeros onto it. 4,000. Last step in solving this. Divide by 125. Divide by 125. What is the volume of this smaller figure? 32. Yeah. It's 32. And we're including units, so it's centimeters. What's volume measured in? Cube. There it is. Now, man, that's a lot of work. You're doing the same thing. It's like anything else we do. You're taking the piece you have, you're simplifying it. You're finding all those ratios. You're matching up the appropriate ratio to find the missing piece. Let me skip to the other one for the second time here. Okay, so we're doing that one, that surface area. Part B is just like it. Let's look at these ones now. Same thing. Question is, what do I have two of? Do I have two surface areas or two volumes? Two volumes. Again, since the volumes of two similar figures are given, the surface area of the smaller one is given. We'll come back to that second. That's key information right there. Yes, Gary?
What about example 4, the window?
Yep, let's give that one. Throw it on. So, do the same thing. We have two volumes. Let's make that ratio. I'm going to do 12 over 96. What should I do to all ratios, all fractions at a time? I should. And that becomes what? What is 12 over 96? 1/8. Very good. So that is 1/8. What was that? That was the ratio of what? Volume, right? So here's my little chart comes into play here. Scale factor, first power. Surface area, the second power. And then I have volume, the third power. You guys told me this was my volume. So I'm going to put a 1/8 right there. What do I need to go to next? I always need to go to this one next. It's the only way I can go. I have to go scale factor. How do you go from volume to scale factor? Uncube it, so a cube root. Very good. So I'm going to take that number, that 1/8 that I had, and I go to cube root them. And nice, you'll see a lot of the same numbers repeating over and over again, guys, so it's pretty nice and easy there. What's a cube root of 1? Yeah, that's easy. Cube root of 8, we've done something similar. This cube root of 8 is 2. All right, great. My chart's still missing. I need to get surface area. What do I need to do that to get the scale factor? I'm going from a small piece to a big piece, so I'm going to have to square it. What's 1 squared? 2 squared. There you go. Now I have it. Notice I'm looking for the surface area. Which ratio should I choose? The squared one, the ratio, the surface area one. And I will. So I'm going to do that ratio. 1/4 is equal to. Where is that surface area going to go? At the top of the equation or the bottom? Which one is this? Do they give you the smaller one or the bigger one? It gives you the smaller one. We want to find the larger one. So since it's the smaller one, it's going to go up top. Over V. We're finding, V, sorry. A. It's area. Area. Well, quick multiply here. Cross it up. 8 times 1 is A. 4 times 12, 48. No need to solve there. It's going to be 48 inches. What are my units in surface area? The surface area. Squared. There's your answer. The larger one is 48. He's just like it.